We're asked to graph this pretty gnarly inequality and solve for where x would make it, what x values would make it true. So we know how to do this algebraically, but we can also do it graphically with our calculator. It's pretty awesome. So really, if you remember, what this is asking is, when is this function greater than this function? So we can actually just put this in our calculator. We can put this whole nasty function in our calculator and then this function in our calculator and see where this one is greater than this one. And again, we're looking for x values that would make them greater, right? We're looking for what x can I put in here that would make it greater. So I go to my calculator and I put this function in. Remember, the absolute value function is in the math menu. If I go to math and then over to number, I get absolute value. So I have my y equals here, and then I'm going to graph this function. And when I first graph it in my regular window, I notice that I just see the blue function. I just see the first one. Because think about it, this second function is 44. So where is that going to be? It's going to be y equals 44. It's going to be way up high, right? So let's go to our graph and let's change our window. So we're going to click window and we're going to do y max of 50. We're going to do a y min of 40. So we're going to just look at the function way up high by where they're going to cross. So there we go. There's our v. Oh, but it only shows one of them. It only shows this side. So we know this is a v because it's an absolute value. So we're going to go back to our window and we're going to do our x min. I don't know, let's say 40. There we go. Now we see our v, we see the top part of our v, and we see where it crosses over 44. So the first question we ask ourselves is, where is this blue function, that's this one, greater than 44? That's our red function. Well, it's greater than 44 here and here. So we have to figure out what those x values are, right? So we know this would be from negative infinity, it's greater than 44, all the way down to whatever this value is. And then from whatever this value is all the way to positive infinity, it's also going to be greater than 44. So let's figure out what that is. So we can go to second, calc, and we're going to calculate the intersection of these two graphs. So it asks, which curves do you want to use? You want to use this first curve? And I say yes. And it says, do you want to use the second curve? And I'm like, yeah. And then it says, give me a guess. And I said, enter. And it shows the intersection is negative 14. So I'm going to write this down so I know that from negative infinity all the way to negative 14, this blue function is above the x-axis. From negative infinity all the way to negative 14. I'm just going to write that down on my paper so that I can remember that for later. And then I'm going to calculate the other intersection. First curve, second curve, and then it asks for a guess. Well, if I put enter again, it's going to give me that negative 14 again. So I'm going to go over to the other intersection. I'm going to push enter, and it told me the intersection is at 2. So I know from 2 to infinity, right, because we're looking at x values, what x makes this true? Anywhere from x equals 2 all the way to x equals infinity, this function is going to be greater than 44. So now I can actually figure out how to write this. So I have, here we go, I know from negative infinity to negative 14 it was greater. Now the question is, at negative 14, what's going on? At negative 14, these two functions are equal to each other. This function equals 44. So do I want to include negative 14 in the x values that make this true? Yes, because I'm looking for x values that would make this function greater than or equal to 44. If I put negative 14 in here, this function would equal 44, which is one of the conditions of mine. So absolutely. So I'm going to go from negative infinity to negative 14. And remember, I'm going to use a closed bracket for that because that means I include negative 14. And the same thing, I'm going to include 2 all the way to infinity because at 2, this is also equal to 44, which is what I want. So now if I go back to Delta Math, this is the key to being able to actually enter it into Delta Math, is understanding some notation. So I'm going to start with, I know from negative infinity. Now remember, negative infinity is not a number, so I can't put a closed bracket on negative infinity. So I'm going to go from negative infinity to negative 14, and I'm going to have a closed bracket. Now this is where the notation gets kind of funky, but this is notation you've got to know how to use now that you're in pre-calculus. This is a U, a union. It basically means either this one or this one is true, okay? Because values in either one of these spots is going to make it true. So we use this, the union, and we're going to say from 2 to infinity. And let's see. There we go. And it gives you a little bit of a hint. If you're not remembering how to do it on your calculator, it'll show you, but this is exactly what we did. See, these x values make it true and these x values make it true. Let's try one more. So here I'm trying to figure out when this function is less than this function. So I put them into my calculator. When is this hairy function less than this function? So I go ahead and graph it. And what I notice immediately when I graph it is that I don't see much of anything because I'm still in the window for the other function, right? We made that window for the other function. So I'm going to go to zoom and I'm going to go to 6. Zoom standard, that's always where I start because it gives me an idea of where it is. This is a 10 by 10 grid. Now I see the absolute value is here, but of course the negative 19 is not showing because it's down low. So let's change our window. I wouldn't zoom out. I would just start changing my window because zooming out sometimes then you end up like the function gets so tiny in there it's hard to see. So I know I want to get down to negative 19. So my y min, I'm going to do negative 20. And remember when you do a negative, you use this negative sign, not the subtraction sign. And then I have a feeling that it's going to get a little wider because, see, it was already kind of over on the edge. So let's do negative 20 for the x min as well. So it's going to go all the way to negative 20 instead of negative 10. So there's my, yay, I got them both, right? So I can see both of the functions on my window. That's the first thing. And then I look and I see where is this function less than negative 19. So I come over to my function and I see that it's less than negative 19 here and here, right? And in this case, I'm not looking less than or equal to negative 19. I'm just looking at less than. So I don't care about this value that's on the line. I only care about the values that are below the line, the x values that create y values below the line. So you know what? I'm going to do my window a little bit lower so that I can just see it a little bit better because it's frustrating me that I only see one. There we go. So I'm looking at these values and I'm looking at these values. So what x values create this and what x values create this? So I'm going to figure out what this point is and I'm going to say every value from negative infinity all the way to this value is going to create one of those y values that's low. So second calc, intersect, because I want to see where these two functions cross. So I go enter, enter, and then it asks me for a guess, so I'm going to get close to that one. I'm going to push enter, and that intersection is at negative 10. So I'm going to write that down so I can remember. And then I'm going to calculate the other intersection. Enter, enter, and then it's for the guess, I'm going to get close to this one. And I'm going to push enter, and it tells me that that's at negative 4. So I have to, again, think about it. This one is, I want ones below the line, so I'm going to go from negative infinity to this value, and then from this value to positive infinity. So I'm going to go from negative infinity to negative 10. I'll show you this when I'm writing here. I go from negative infinity to negative 10, and this time I don't want the values right on the line. I don't want this function to be equal to negative 19. I only want it to be less than negative 19. So at negative 10, this function is equal to negative 19, which is not what I want. So I'm going to have an open bracket. I don't want equal to, I just want less than. And then from negative 4, to infinity, I'm going to have values as well. So we can go ahead and put that in here. So we're going to have open brackets for both of them because infinity is not a number, so we cannot have a closed bracket for something that's not a number. So I go from negative infinity to negative 10. And let's try the OR here and see if that works. I believe it should. Either the union or the OR should work. There we go. So in the last example, I used the union. In this one, I used the or. Both of them work the same. They're just a different notation. But again, I'm looking at these values here or these values up here.